Have you ever wondered why a metal bridge has small gaps between its sections, or why a glass jar lid becomes easier to open after running it under hot water? The answer to these seemingly unrelated questions lies in a fascinating physical phenomenon known as thermal expansion. At the heart of this concept is a fundamental truth about matter. When heated, most materials expand. But how does this expansion occur, you might ask? Well, it's all about the way particles of matter behave. When a solid material is heated, the kinetic energy of its particles increases. These particles begin to vibrate more vigorously, and as a result, they need more space. This causes the material to expand. This is what we call linear expansion. Linear expansion is the increase in any one dimension of a solid, such as the length. It is defined by the linear expansion coefficient, which represents how much a material's length changes for each degree of temperature change. The higher the coefficient, the more the material expands when heated. For instance, consider a metal rod. If we heat it up, the rod gets longer. This is linear expansion in action. The rod doesn't get thicker or wider, it just gets longer. But what if we were to heat a three-dimensional object like a cube? This is where volumetric expansion comes into play. Volumetric expansion is the increase in volume of a material when it's heated. Just as with linear expansion, there's a coefficient for volumetric expansion. This represents the change in volume per degree of temperature change. If we heat up our cube, it doesn't just get longer. It gets wider and taller as well. It expands in all three dimensions, increasing its volume. Now you might be thinking, is there a connection between linear and volumetric expansion? Indeed there is. For isotropic materials, materials with properties that are identical in all directions, the volumetric expansion coefficient is approximately 3 times the linear expansion coefficient. So, to recap our discussion today, thermal expansion is a physical phenomenon that causes materials to expand when heated. This expansion can be in one dimension, which we call linear expansion, or in all 3 dimensions, which we call volumetric expansion. The extent of this expansion is determined by the material's linear or volumetric expansion coefficient. Remember the bridge and the glass jar lid? They are everyday examples of thermal expansion. The gaps in the bridge allow for its expansion on hot days, and heating the lid of a jar makes it expand, breaking the seal and making it easier to open. Understanding thermal expansion is not just crucial for engineers and scientists, but also helps us make sense of everyday phenomena. So the next time you notice something expanding or contracting with heat, you'll know exactly what's happening. It's all about the dance of particles, the rhythm of heat, and the marvel of thermal expansion.